What's up, everybody? This is Matt Brown with another IoT hacking video. Today I have the computer modules from my smart grill device made by Masterbuilt, and we are going to take this apart and see how it ticks on the desk. I actually have the real one that I took off my grill, and then I have one I acquired from eBay, and there's some interesting differences. This one actually did not work when I attached it to my grill, and so we're gonna kind of analyze why that could be the case, and we're going to dump firmware from these devices, and we're going to do some analysis of that firmware. So let's go over to the workbench and get started. So, like I mentioned, right here I have the module that I actually pulled off of my real working grill that that was an official Masterbuilt grill. And then this is what I got. That was a replacement module from eBay. I was not through any official Masterbuilt channel, and you can already see from the front that it is missing the Masterbuilt logo on the front, so that's already a little bit sketch here. And when I took a look at the inside of this, I saw more differences. Now, what's really funny about this is that when I started this project, I initially did not want to rip apart my actual grill, and so that's why I got this thing off eBay. And so it was when I tried to, use my smartphone app to actually do the Bluetooth pairing and to set up this device, and it failed, that I tried to dig into why that was failing, and I ended up having to perform some analysis on my legit one of these PCBs. So that is the task set before us. So first, let's take a look at some of the obvious kind of differences. So again, obviously the PCBs are of a different color, and so we can see that there are some markings that have been marked differently here, but overall it's obviously the same device. I don't believe that this is a counterfeit. That's kind of my spoiler here. So let's zoom in and look at the eBay device here, and we can see that it reads here that it has V07, okay? And then up here on my board that came from my operating grill, we have V8. And then we even have a date here. So this is 2019 11/18. And this says 2019 7/12. So these are clearly from a different run, a different production run. And another interesting fact is that although these look identical now, this eBay version came with these debug pins on this programming header, which we will be using a lot in the coming parts of this video. This was already included on this board. I did not have to solder this on, whereas on my operating grill, I had to solder. I had to, supply my own pins here and solder those onto the programming header because they were not included. So my best guess is that what I have here up on top is some kind of a pre-production run of the device, and somebody from Masterbuilt or this thing fell off a truck and somebody's trying to make some extra money by selling this as a replacement computer module on eBay, and or the other alternative is that maybe it was legitimate. It legitimately worked at one point, but there was a app update and the BLE communications to do the initial pairing of this device just don't work anymore because they pushed some software update to the new ones. So that's my working theory, and then I wanted to dig into the firmware because we obviously have right here the key part of both of these devices. So what I'm going to do is I'm going to move forward with all of the kind of PCB reverse engineering on my grill's device here, and if we brick it, hopefully we can flash the firmware from the good grill, which I already have a copy of, to this, and then I can turn this into a actual functioning replacement, which would not have been possible without the firmware extraction that we're going to do in this video. So let's zoom in here And yeah, we're actually going to take a look at this under the microscope. So I'm going to pop this off here, and you can see at the front, we just got some of that stuff there. So just if you're not familiar with the grill, what we have up front here is we have, obviously like the control buttons, the LCD screen. Here we have kind of a turn switch here that we can set the temperature, and then we have a bunch of temperature probes that we can plug in. And the key thing that we're going to be taking a look at today is all right here. This device is powered by an ESP32. So this ESP32 is capable of doing both Bluetooth Low Energy, which is how the Wi-Fi credentials are given to the device. We kind of went through some analysis of that traffic in our first video on this device. And it also does Wi-Fi, and that's how it actually connects to the cloud, and you can change the temperature of your grill or monitor it from anywhere with an internet connection. And then we have this programming header. It's very clearly labeled there, and so we're going to actually switch over to our microscope, and we're going to take a closer look. We get some light here, and let's get that in focus for you all. Whoops. All right, there we go. So this is pretty clear cut what we're going to need to do here. So if you're not familiar with the ESP32 target, the ESP32 actually has external to the microcontroller, but internal to this shield here, there is a SPI flash chip inside of here. So if we really wanted to, we could yank this shield off, and we could desolder the flash chip, and we could get at it. But there is typically a easier way with the tooling around the ESP32 platform. And so we are going to do that with this handy programming header. So like I said, this is the legit device off my grill, so I did go ahead and solder in a pin header here, and it's just useful to note if somebody's going to try to recreate this, that this is not the most common pin header. These are actually a bit smaller than your standard pins. So here's kind of, I don't know what the millimeter measure is, but this is your standard kind of pin header here. And you can see that you're not going to be able to fit more than one of them. You're not going to be able to fit like those side by side there. So I do have some special wires. So right here we need to obviously reverse engineer this, but it's going to be pretty easy with the data sheet at hand. Wow, it's like not staying in focus. Let's fix that. That's much better. Okay, so we're going to come over here and we're going to take a look at our data sheet. So we've got a couple data sheets up here that we're going to be looking at. The first data sheet is for the very specific ESP32 package that we have on this board. And so it is the ESPW room 32U. So this data sheet encompasses the 32D and the 32U, and we're not going to worry about the differences of those because we really don't care about that. What we are going to do is we are going to go to the pin layout right here, and we're going to look for a couple of pins. So what we want is we basically need 4 pins. We need ground, TX, and RX. So it's going to be a UART signal. And then additionally, there's going to be one more pin that we're going to need. But actually, let's just start with those 3. So let's go over to the board and we're going to find those. But in order to find them, we can be aided by this diagram here. So we can see here that on the right side of the PCB, we have 1, 2, 3 pins, and then the 4th pin is TX and the 5th pin is RX. So back to the scope, we can kind of count these off on this side. So 1, 2, 3, TX, RX, and so what we're gonna do here is I'm gonna flip on our multimeter overlay, and we're just gonna go ahead and device is disconnected, and we're gonna probe Okay, so here's our TX pin right here. Okay, so that's our TX pin. And then right here, that is our RX pin. So we have over here, again, we have TX, RX, and okay, let's find ground. So I'm just going to assume that this is shielded right here on top, and we're going to go through here. And there we go, we have our ground pin right there. So again, TX, RX, ground. And so those 3 pins we have, okay, I will go ahead and kind of give us the hint about the next pin we're going to get, just because I'm going to connect the header up all right now. So there's one more pin we're going to need when we do the next step. So our first step with our UART adapter is we just want to see if we get output over the UART line, which, spoiler alert, we are, and it's going to be really helpful information for reverse engineering the grill. But when we go to do firmware extraction over this UART interface, there's a very special ESP32 specific way that we're going to do that with the ESP. So what we're going to do is we're going to come over here, and we can run the following command to, if I can properly know how to copy and paste it. So this is the command we're going to run when we're going to dump the ESP32 firmware over our UART connection here, right? So that's going to fail. Here, we'll do that. And so obviously we have ESP32 or ESP tool. We're targeting the ESP32. We're giving it our UART port, and then we're saying like read flash, right? Well, how does this thing work? How can this tool, you know, dump the firmware over UART, right? Because UART isn't that's typically just going to be a way during the normal boot up of an ESP32. It's just going to be a way to communicate with the application's, you know, UART console, whatever that is, whatever's implemented there. But if we're gonna take a look at the just general ESP32 data sheet, and we are going to go down here to boot configurations, and we're going to look at some of the different boot modes that we can put an ESP32 into. And if we go right down here, so here we can see that the chip boot mode control. So this is a way we can control what boot mode it goes into. And the default mode is SPI boot mode, right? Again, it's got that flash chip that the microcontroller communicates with SPI, and it's going to, you know, load the firmware and be off to the races running that firmware. That's the normal situation, but we have this joint download boot mode that if we set GPIO 0 to 0, so if we pull that down to ground, then we can enter one of these modes, either SDIO download boot or UART download boot. So effectively what that's going to do is it's going to allow us to run code that we give it over UART. Well, the ESP tool Python program is going to implement the read flash operation when we put the device into this mode. So what we have to do is we have to go back to our other data sheet now and find where GPIO 0 is mapped. So over here we can see on the device, we have IO 0, which is pin 25 right down here on the bottom right. So now we're going to head back over here, and we're going to identify that pin. So right over here, get probes out. So you can see here, I've got one probe there, and then I'm going to go down the line. I swear this is connected. That's so funny. That's so funny. My multimeter is clearly having a problem. Well, you might just have to trust me that this is actually connected. You know what? I think yeah, there we go. My continuity threshold is not like, the resistance threshold is not set very well there. But we can see that that is in fact where the GPIO pin 0 is. And so if we want to put it into that special boot mode, we need to just ground out this pin right here. We're going to have to connect that up to ground. So that is good for us to know. All right. Doggo, what are you doing? What are you doing? He's like, it's late. We need to hack things. All right. So, where were we? Back to UART. That's what we're going to do. We're not going to read firmware first. All we want to do first is just be able to get the UART output when we go like this. Okay. So what we're going to do is we need to rig that up here over on the bench. Let's get rid of this. All right, we are in focus now. So, like I mentioned, I've got my little wires here, and I have 4 of them, so I'm going to just connect those up to my breadboard here. There we go. And then I have those all mapped over on this breadboard, which is not important for now, but it's going to be helpful later when I want to take this middle pin right here and I want to connect it to ground. So right now I just have this floating, so it will be in the normal boot mode, but when I want to connect it to ground, the enable pin, I will do so. So right now we're just passing this through to our UART cable right here. Let's zoom out a little bit. So you can kind of see the setup there. So we're just passing that through, and then the breadboard is really just so that when the time comes, we can connect, we can pull the GPIO 0 pin low. So there's our setup. Now we are going to run our terminal here, and I'm simply going to plug in the device, and we get to see some awesome, very useful output scrolling by. And yeah, just super helpful for reverse engineering this device here. Here we get a very good look at the partition table on the device. So when we do dump the flash, we're gonna be able to know what all is contained in this flash, at what offsets, what each partition length is. Super useful stuff. Yeah, more information about that. Let's keep scrolling down because this is just super useful. Okay. All right, we're back, and the dog has been dealt with. So here we can see, like we were talking about, that we have a bunch of stuff that is related to the Amazon IoT AWS service. So, and we can see what the identifier of the thing is, which is really useful, and this is going to come in handy later, right here. I'm actually gonna I'm gonna copy this down and I'm gonna put it in my notes here on the side. All right, so, and here we can even see some kind of JSON data that's coming back here. So you can see the MAC address of my device, a bunch of other information about the temperatures. Obviously the temperature sensors aren't hooked up, so a bunch of this data is not going to be accurate. Bunch more stuff about the device. So we're just seeing a lot of the interactions with the AWS APIs, a lot of the details here that's getting printed out over UART, which is super helpful if we're going to start trying to attack this or do anything with this AWS service, which is it's usually like MQTT over TLS is what's going on here, and there should be mutual authentication going on, which we will find some things related to that in a little bit. So yeah, it's just gonna scroll and do the same thing forever. Okay, but now what we want to do is we want to actually switch modes now. So let's go over to our bench for a second. So I'm going to power off the device, and so now all I'm going to do on my little breadboard is I'm going to connect up is I'm going to ground out that GPIO 0 pin. Okay, so now we are set up, and we do not need our overlay anymore. All right, so we're back over here. Let's reset that. All right, so here is our firmware read command, and we are going to, yeah, that's fine. We'll call it firmware.bin for now, and we're gonna hit that. It's gonna try to connect, and we're going to turn the device on, and now it is going to run our firmware extraction, and this is going to take a while, and that's why we are going to, I actually already have this over in another folder. All right. Yeah, right here. Okay, we're gonna stop that. So as you can see, we were able to dump the firmware. It does take a while. It takes like a couple minutes to do the full dump, but then you get something that looks like this, right? So we've got all of these dumps here. So I've done this multiple times. And so what I have here is on this V7 dump 1 file, this is the dump from the eBay like potential dev board. It's non-operational, right? So I just have the one dump from that device. And then what I have, what's kind of interesting, and this is gonna lead us to some very cool analysis that we can do, is the difference between this V8, which is my legitimate board from my operational grill computer, is this has been, factory reset. It's just not configured, this device. And then this second dump has been performed when I have configured Wi-Fi credentials, and it is, it is operational and is connected to the AWS backend. And so we'll be able to diff these two firmwares and kind of see some interesting stuff that's going on in there. So first, I want to diff these two because that is kind of going to be a fun exercise as well. And we'll just see what happens. So here we can see right off the bat, so we're just using vbin diff to do this. And we can scroll through this, but what I really do believe, oh yeah, actually, let's like run strings on this. Oh yeah, I remember how I did this. Let's go like look for, let's just like look for, we're just gonna do a regex that looks for like number dot a number, so like a version string, right? And so here we can see, oh yeah, so v3.3 dirty, which I believe is a reference to just like the ESP library. So yeah, so we can probably also look for that in the newer one. Let's just do that. And here you can, okay, so this is an interesting difference, right? So obviously this is running, the newer board that I have is running v4.2 dirty, and here we're running, the older one is running 3.3 dirty. So there's a completely different firmware on these two devices, which probably lends itself to why I can't do the setup process from the up-to-date mobile app. Again, maybe there's an ancient version of the Masterbuilt mobile app that will allow me to correctly interact with this older board, or it is just a dev board that fell off a truck that they're trying to sell on eBay. Who knows what the story is there, but I just know that it does not work with the most up-to-date app. So now for like what I think is the cooler part of the analysis is, let's take a look at what happens between an unconfigured device and the configured device. And we're going to find something that, if it's not, we're going to find something that might be an outright vulnerability and some other things that might smell like vulnerabilities, right? And might need a little more prodding to figure out if they are real vulnerabilities, okay? So let's just go ahead and do this, and I'm just hitting the key enter, and then that goes to the first difference. Okay, so we're looking for differences between these files here, right? Okay, so we hit this section, and now down here in the bottom, what we have on the bottom here is the device that has been configured. And okay, we're seeing a certificate. That's pretty cool. So we got a certificate, another certificate, some stuff, some stuff, some stuff. And here we have LabNet and my lab Wi-Fi password. My new password is set up. Too Many Secrets. If you haven't seen the movie Sneakers, best hacker movie of all time, hands down. So you got to go watch that. But we have LabNet and Too Many Secrets. So that is our SSID and password. And if you're one of those people that think that that needs to be encrypted on flash on all your IoT devices, we could argue about that in the comments, whether you think that needs to happen. There might be some IoT regulations that are coming down the pipe that would require that, and that really depends on how you interpret those regulations, which are very gray and fuzzy. But we in fact very clearly have on an external flash chip on this Grill computer, it has the SSID and password in clear text. So that part of it is not debatable. Whether or not it's a big deal, we could definitely debate that. So if we scroll through here, there's, okay, so there's some more stuff. Okay, so now this is interesting because now the more recent one has a certificate in it, which is, pretty interesting. Okay, so maybe it just had the certificate at a different location, right? And there you can kind of see that same section where it could have had like an SSID and a password, and we can see that it's very clearly like not configured in there. So I'm gonna hit enter, and we have no more differences, okay? So, but we saw some there's a ton of interesting data that kind of looks like it's all in that same area. So let's go ahead and let's actually take a closer look at this via just looking at some strings. So let's look at the strings of the unconfigured device, okay? Let's hit less. And I'm just hitting the page down key to just kind of cycle through these here. Look. And we're starting to see some stuff that has to do with certificates, and for some reason it's cut off and stuff like that. And then we see an RSA private key here. So in the unconfigured device, there is an RSA private key, right? Which potentially means that is hard-coded once into the device, right? So if the people that sold, this falling off the truck, old development board, right? If you wanted to do some supply chain attacks, you could read the RSA private key off of one of these devices, and then you could sell it as a replacement unit out on the marketplace. And then when someone else configured it onto their actual master-built account with all of their credentials and everything, when it connects to the cloud, it would potentially use the same private key, right? That's being used to do that mutual authentication to the AWS APIs. So if that is what's being done, this is a pretty big vulnerability, I would say. So yeah, we see some more certificates, yada yada yada, references to the firmware version, things like that. And so obviously, if we run this on the second dump, we would be able to hit page down, and I would be able to find my Wi-Fi password again in here. And if we scroll down, okay, we see there's the cert, there's the key. Okay, yeah, and it's very clearly like the same key, right? The same private key in both places, right? Because we didn't see that difference when we did vbindiff, right? And so if we keep going down, we do see that our differences here are, we have our SSID of LabNet, and we have Too Many Secrets, and that is our password. So next, what I want to do is I want to in a future video. So that's it for this video. Thank you for watching. But my plans now are to start doing some reverse engineering. So now I have all this firmware off of here. Now we can start loading it into a disassembler and start to look at the functions in there, right? Because my big picture goal here, like I mentioned in the first video, I had this hunch. I had this hunch that there's a way, not only we found out how to read the temperature over Bluetooth, but what if there's a way to set the temperature over Bluetooth? Well, we might need to reverse engineer the application here, and now we have the code. So that is where we will be going next in this video series. Thank you for watching, and be sure to like, comment, and subscribe. You have a good day.